My General Electric dryer has been getting progressively louder and louder. So much so that I can't ignore it anymore. I'm afraid something will either snap, break off, burn out, or catch fire. So it's time to take a look at it, which means getting my tools and taking the entire machine apart. If you just pry the top of the dryer a bit at the front, you'll see where the cover latches onto the rest of the dryer. The top flips up much like the hood of a car. Slip the ground wire off and pull the top cover away from the back latches after a bit of fumbling. Spinning the drum at this point is the practical equivalent of kicking the tires of a new car or slapping a pile of something which has been strapped down and stating, "That's not going anywhere." There are 2 screws which need to be removed to unlatch the front. And here's something I just found out. This type of combination Robertson-Phillips screw actually has a name. It's called the Hammond M6 Quadrix. They're usually rack mounting screws and they work well with a number 2 Robertson head. Once those are out, you can pop the front cover off. You'll then need to lift the cover up from the bottom cabinet clips. I pushed the front cover aside without disconnecting the wires so I could test the dryer. At the front here, 2 things keep the drum aligned. The plastic glides clipped onto the inner rim of the drum and the felt seal glued to the outside of the front panel all around the doorway. There are 3 screws holding the drum to the rear drum support. And 1 clip at the top. Then you can pull the drum out the front while easing the drive belt back. Or you could open the back panel and ease the tension by pulling the idler arm assembly back and then slipping the drive belt off. If my sequence of actions looks a bit weird, that's because I'm slipping the belt back onto the pulley. I just reversed the footage. Without the drum in place, I plugged the dryer back in and tried again. And now I was certain the loud noise was coming from the motor. Next, the blower wheel needs to be disconnected from the motor. I clamped locking pliers onto the motor pulley just tight enough to hold it still, but not enough to damage it, and then used a 7/8 socket on the blower wheel's plastic nut thing. But since it's reverse threaded, I applied tension clockwise. It'll be threaded on tight, so apply lots of steady pressure while keeping the nut deep in the socket so it doesn't slip and strip. The motor mounting clamp is unlatched by applying some downward pressure and slipping it out of its anchor prong. Pull the blower housing lock and... okay. Yeah, the wire harness should have been removed by now. I vacuumed the motor and then blew some compressed air to clean it out. I thought maybe one of the bearings had failed and the motor would start the grinding noise as I rotated it with a drill. Nothing. All good. Maybe the cleaning had done its job. So I dropped the motor back in, strapped the motor mounting clamp back into place, slid the blower housing lock, and then noticed a small detail. That plastic component is sort of guillotine shaped, and the part which secures the motor to the blower housing has a slight lip. The motor had slipped out from under the lip, so maybe this very slight misalignment of the motor and pulley and blower housing wheel was causing all that noise. Possible because it was now purring along nicely. Before I move along, the wire harness goes to the side of the motor, not the top. I had to correct that by removing the motor mounting clamp and turning the motor 90 degrees counterclockwise. Maybe unrelated, but I had the impression that my dryer was overheating, so while I'm at it, I'll check the control thermostat. Out of this model's 3 thermostats, this is the one which regulates the heating element's temperature. The other 2 thermostats completely shut off the dryer if it overheats. If they'd been triggered, my dryer simply wouldn't work at all. Unclip the 2 leads from the thermostat and remove the 2 screws. I'm using a flexible drill bit extension to work around the tight space. The control thermostat, sometimes called a cycling thermostat, a high limit or safety thermostat, turns power off if or when the heating element reaches 126 degrees Celsius or 260 Fahrenheit. I tested mine by attaching multimeter leads, setting the meter to continuity, and then applying heat from a heat gun. As long as the temperature remains within limits, the thermostat will allow a current to pass but will shut off if overheated. After a pause, it closes the circuit again and allows current to pass. I tested the thermostat several times and it's all good. Securing the drum at the back of the dryer is the rear bearing shaft support, which looks an awful lot like the hitch ball and coupler you'd see on a trailer. I'm vacuuming and cleaning off that dark gunk, probably dirt and grease, and applying some white lithium grease. Most important of all, that 7-watt bulb, which burned out I don't know how many years ago, because honestly I can barely tell the difference if it's lit or not. Now this is how you reattach the drive belt. From the back, through the access panel. The belt has ridges on one surface which mate with ridges on the belt pulley. The idler arm assembly holds the pulley, that white plastic wheel, and keeps tension on the belt. Also, if the belt were to snap, fail, fall off, the arm would be pulled back by the spring, triggering a micro switch, shutting off power to the dryer. The drum needs to be slightly lifted to align the felt seal into the plastic glides of the inner rim of the drum as you snap the dryer's front panel. Front panel screws. One clip at the top. Top cover. Ground wire. And snap it back into place. I plugged the dryer, slid the lint filter back in, and started it up again to hear it purring along softly once more. If you do this, finish up with a good long hug to let your dryer know how happy you are at keeping it around many, many more years.